Hey people, so today we're gonna learn what is dimensional analysis and its application. It is a concept from class 11th NCRT Physics Part 1. So let's try to understand what does it say. So first of all, to understand this concept, you need to know what is dimensional analysis, or let's say the dimensional formula first of all. I write it down here. Dimensional formula. I tried to make you understand this concept using a very simple example. Let's take the example of a speed. You might have already known that the formula of a speed is equals to distance upon time. If there is a body, it covers certain distance in a certain time, then the speed of the body will be considered as distance upon time. Alright? You are already aware of this thing. So basically, if we try to look at the speed is basically formed with two basic quantities which cannot be broken further. The two basic quantities in this case is actually, first one is distance, second one is time. So we can say that speed is a physical quantity. It is a physical quantity obviously, and it is written in the form of two basic quantities, distance and time. So speed can be broken into two basic quantities which are distance and time, but you cannot break further distance and time. So the dimensional formula of speed will be written in the format of distance and time. Let's say the dimensional formula of distance, here I am representing distance with a capital letter D, and dimensional formula is represented by these closed square brackets. So the dimensional formula of distance is actually written as L. Let's say this is the dimensional formula of distance. Actually, in the similar format, the dimension formula for time is actually capital T in the closed square bracket. This is the dimension formula of time, and this is the dimension formula of distance. All right, I hope you are here with me up to this point. So we can say that the dimensional formula of speed, let's say speed we are representing by capital letter S closed in capital square bracket to represent in the form of dimensional formula. So the speed can be written in the format of distance and time as distance over time, or it can be written as L t to the power minus 1. T here it is in division, it goes up, the power goes negative. I hope you are aware of this very simple mathematics. So this is actually representing the dimensional formula of speed. Usually there is one more basic quantity. Here are two basic quantities, one is distance and one is time. Why I am calling them as the basic quantities is because they cannot be broken further in more simpler quantities. All right, you cannot write distance in the format of some more simple quantities, but you can write speed in the form of distance and time. So speed is actually a derived quantity, and these are actually the basic quantities, or using them the formula of speed is derived. All right, so the dimension formula of speed comes out to be Lt minus 1. If we take mass as well in our picture, let's say the dimension formula of mass, which is written in the form of capital M closed in square bracket, then the dimension formula of speed can be written as, if we take mass as well in picture, m to the power 0 Lt minus 1. So this can be written as the dimension formula of speed. Here mass is raised with power 0, so it is same as Lt minus 1, nothing to worry about from where this mass has come up, but it is raised with 0. So to basically to make the mass as well in picture, because if you will follow the NCRT format, usually every dimensional formula is written in the format of M, L and T, and they are raised with some power to make it compatible. So this is basically the dimension formula. I hope you have understood up to this particular point. If I try to give you one more example, let's take the example of work done. We are representing work done by capital letter W. Actually, the formula for work done is force multiplied by displacement or distance. Let's say there is a block which is pushed by some force F and it travels a distance S by this particular force. Then the work done by this particular force is actually force multiplied by distance, which is represented as S. Force can be broken into more simpler quantities. The formula for force comes out to be, formula for force is basically mass into acceleration. Mass of this particular block and the acceleration with which it is going in that particular direction, that is actually the force. And the formula for acceleration can be broken further. It is basically speed over time. Basically it is the rate of change of speed, so that's why I write it as speed over time. As we have seen just before, over here the speed is basically distance over time, so acceleration can be written as distance over time into time. All right, I hope everything is clear up to this point. Time into time comes as time square, because there is time into time. So this way the dimensional formula for acceleration, let's say it is represented by capital A closed in square brackets. It comes out to be dimension formula for distance, which we are representing as L, and time square, which is represented as capital T to the power 2. So it comes out to be LT minus 2. All right. If we try to write the dimension formula of force now, let's say that force we are representing as capital F closed in square brackets. So it will turn out to be the dimension formula for mass into dimension formula of acceleration. Dimension formula of acceleration we have found over here as LT minus 2. So the dimension formula of force will be mass into LT minus 2. This is the dimension formula of force. So here you can see all the three basic quantities: mass, length and time. Actually there are 7 basic quantities if you will go through the literature, but here we are just using 3 of them: mass, length and time. Basically what we are doing is we are breaking every physical quantity into 3 basic quantities: mass, length and time. That's what happening here. So the dimension formula of force can be written as MLT minus 2. You can cram this up. So this way the dimension formula of work done, if we'll try to find the now we have the dimension formula of acceleration as well and the force as well. So the work done is basically the product of force and acceleration. So the dimension formula of work done will be equal to MLT minus 2, which is dimension formula of force, into LT minus 2 into just L. No, sorry, I'm sorry about this. The dimension formula of sorry over here. Let's go over once again. This is the last part, I messed it up. The formula for work done is actually the force into distance, not force into acceleration. So the formula of work done is basically the force into distance which we are representing as L as the dimension formula. So the dimension formula of force is actually, we have found mlt minus 2. And the dimension formula of distance, we already know, we are representing it as L. So the dimensional formula of work done will be ml2 t minus 2. I hope it is clear to you all. So in this way we can find the dimension formula of anything. Alright, I hope you have understood up to here. Okay, if you haven't understood till now, let's take one more last example. Let's try to find the dimension formula of kinetic energy. I hope you already know the formula for kinetic energy from your 9th class science, which is half mv square. If there is a body of mass m going with a velocity v, then the kinetic energy stored in this particular body is this much, half mv square. Let's try to find the dimension formula of kinetic energy. We are representing kinetic energy as Ke closed in square bracket to represent it in the form of dimensional formula. What is the dimension formula of this half? Half doesn't have any dimensional formula. It is not a physical quantity. It is just a constant. So constants do not have any dimensional formula. You should keep this thing in your mind. Only mass is having dimension formula. Velocity is also having dimension formula because they are physical quantity. Dimensional formula is always of some physical quantity, not a non-physical quantity. Half is just a constant. It is not a physical quantity. That's why half does not have any dimensional formula. So the dimension formula of kinetic energy will be the dimension formula of mass, which is capital M, and dimension formula of velocity, which we have already found. Velocity or speed and velocity are two same thing actually. We've just found earlier the dimension formula of speed, or this is the dimension formula of velocity as well, lt minus 1, because speed and velocity are the same thing. So the dimension formula of velocity is actually lt minus 1, but in our use case it is raised with the power of 2. So lt minus 1 raised with this square. So the dimension formula of kinetic energy will turn out to be m L2 t minus 2. This is the dimension formula of kinetic energy. Alright. So alright guys, thanks for being with me up to this particular point. I hope you enjoyed this video. In the next video we will solve some numericals demonstrating the application of dimensional analysis. So please be with me in the next video as well, and see you in the next one. Alright guys, bye. Thank you so much.